Welcome to Study Loop.
Let's evaluate the definite integral from 1 to 2. We have a polynomial divided by a polynomial, and the denominator is already factored. So using what the textbook would call case 1 here, in the section they refer to this as case 1. We have 3 distinct and linear factors, so the partial fraction decomposition should look something like a over y, b over y plus 2, c over y minus 3. Now we could go ahead and multiply both sides by this denominator over here. So after multiplying, 4y squared minus 7y minus 12 on the left. On the right, we have a, y plus 2, y minus 3. And then for b, we have y and y minus 3. And finally for c, we'll have a y and a y plus 2. So let's just go ahead and rewrite this left hand or the right hand side. Just multiply things out. Y squared minus y minus 6. This is for a. And then for b, y squared minus 3y. And for c, y squared plus 2y. Now one more thing to do here on this right hand side is to just rewrite it by factoring out. First, we'll factor out y squared. We'll have a plus b plus c. One here, and one there. Then we'll have, after we factor out a y, we'll have a minus a minus 3b plus 2c. And then finally, the constant term on the right-hand side is just minus 6a. So on the left-hand side, the constant in front of the y squared is a 4. On the right-hand side, a plus b plus c. That gives us an equation. Similarly, for the y term, we have a negative 7 on the left, and this is what we have on the right. That gives us our second equation, minus a minus 3b plus 2c equals minus 7. And then on the left-hand side, the constant term was minus 12, whereas on the left-hand side, it was minus 6a. So we can go ahead and, those are our 3 equations. We have a 3 by 3 system, an a, b, and c. So taking this last equation here, we see that a is 2, so there's already one of our values. And now let's just go ahead and plug this a value into the previous 2 equations. So we'll replace that a with a 2, and this over here, that'll become minus 2. And then we can rewrite the equations. So this first one here, that just becomes b plus c equals 2. And for the other equation, add that negative 2 to the other side. We have minus 3b plus 2c equals negative 7 plus 2 is minus 5. So let's go on to the next page. I'm running out of room here. But we will have this 2 by 2 system in b and c to solve, and then we'll have our coefficients. So we had 2 equations from the previous page. We had b plus c is 2, and minus 3b plus 2c is minus 5. So let's just go ahead and solve this for b or c. So taking this first equation, c equals 2 minus b, and then plug this into the second equation. We'll have negative 3b plus 2 And then our c is 2 minus b. And the right-hand side is -5. So let's just go ahead and solve this for b. So we'll have minus 3b, and then minus 2 more b, that's minus 5b. And then we have a plus 4. So maybe add the 5 to the left, and then push the 5b to the other side. And then we see b is just 9/5. And then, using this equation up here, let's solve for c. So plugging b equals 9/5 in, we have c equals 2, which is 10/5, minus b, which is 9/5. That leaves us with 1/5. So now we've found our coefficients, a, b, and c. On the previous page, we found that a was 2, so let me just rewrite that here from page 1. And then now let's go on to the next page. So let's rewrite the original integral, 1 to 2. Y plus 2, y minus 3. This is what we intended to evaluate. We just did the partial fraction decomposition. We found a, b, and c. So now let's go ahead and plug those in. So a over y becomes 2 over y. B over y plus 2 becomes 9/5 over y plus 2. And then we found that c was 1/5 over y minus 3 dy. And this is a much easier integral for us. If this plus 2 and minus 3 are throwing you off, you go ahead and do a u sub here. U equals y plus 2. Or for the second one, u equals y minus 3. Let's go ahead and evaluate those integrals. The first one, 2 natural log, absolute value y. The second one, that's a 5 in the denominator, 9/5, and then natural log y plus 2, plus 1/5, natural log absolute value y minus 3, and then our endpoints, 1 to 2. Let's go ahead and plug in those endpoints. So plug in the 2 first. Then we have natural log of 4 plus 1/5, and then we have 2 minus 3, which is minus 1, but then absolute value gives us a 1, so natural log of 1. Now we plug in 1 for y. We have 1/5 natural log of -2, but then we take absolute value, that's a 2 there. And now we cancel and simplify as much as we can. We know that natural log of 1 is 0, so these go away, 0 and 0. That's the whole term there. And now we combine as much as we can. So we have 2 natural log 2 minus 1/5 natural log 2. We can write that as 9/5 ln 2. And then we have 9/5 ln 4 minus 9/5 ln 3. And here we can, that can be our final answer. It's a number, but we can go ahead and combine. So here, let's write this 4 as 2 squared. And then using the properties of the logarithm, we can pull out this 2 in front of the 9 and then multiply. So we have 9/5 ln 2, and then 2 times 9, so we have 18 there, over 5, minus 9/5, that should have been an ln of 2, minus 9/5 ln 3, and then just combine those first 2 fractions. And we have 27/5, natural log of 2, minus 9/5 ln of 3, and there's our final answer.